Welcome to school year 2020-2021. As you are enrolled in the science, technology, engineering, and mathematics trend of the academic track, it is needed that you must study the different natural sciences. One of them is physics. So this is General Physics 1, and we are your teachers for this subject. Ms. Mika Margaret C. Andres, Mrs. Jovi Jane D. Sabiano, and Ms. Angelou D. Kaole. For the first week in this subject, we must deal with conversions, problems, and applications of measurements as they are necessary to interpret different values in physics, and this will all be discussed in the systems of measurement. Physics as an academic discourse doubles with very small numbers to the very large, as we do not have time nor the resources to identify and write all of these numbers digits. A notation system was formulated to interpret and present the most significant of these digits and these lengthy numbers, and we call it the scientific notation. So how does this scientific work? We have prepared 5 examples in order for you to understand the concept of scientific notation. Number 1. Convert 29,374,270,000 into scientific notation. First, position the decimal point to get a number between 1 to 9. Second, count the number of places the decimal points move to get the number between 1 to 9. Third, write the number as a product between 1 and 9 to a power of 10 using the number of spaces the decimal points move as your experiment. Lastly, get the two decimal places. Since the decimal point was moved to the left, the exponent is positive. Example number 2. Convert 0.000753 into scientific notation. Position the decimal point to get a number between 1 to 9. Count the number of places the decimal points move to get the number between 1 to 9. Get the two decimal places. Since the decimal point was moved to the right, the exponent is negative. Example number 3. Convert 3,200,400 into scientific notation. Position the decimal point to get a number between 1 to 9. Count the number of places the decimal points move to get the number between 1 to 9. Write the number as a product between 1 and 9 to a power of 10 using the number of spaces the decimal points move as your experiment. Get the two decimal places. Since the decimal point was moved to the left, the exponent is positive. Example number 4. Convert 26,347.32 into scientific notation. Position the decimal point to get a number between 1 to 9. Count the number of places the decimal points move to get a number between 1 to 9. Write the number as a product between 1 and 9 to a power of 10 using the number of spaces the decimal points move as your experiment. Lastly, get the two decimal places. Since the decimal point was moved to the left, the exponent is positive. Last but not the least example number 5. Convert 0.0030722 into scientific notation. Position the decimal point to get a number between 1 to 9. Count the number of places the decimal points move to get a number between 1 to 9. Write the number as a product between 1 and 9 to a power of 10 using the number of spaces the decimal move as your experiment. Lastly, get the two decimal places. Since the decimal point was moved to the right, the exponent is negative. After we learned of the most systematic of ways to handle numbers, we have to look into the different measures and how they interpreted or converted from one unit to another. We all know that both centimeters and meters measures length, as so with feet and inches. But how can they be equated with one another? We have what do we call the International Standard of Units. Now, Let's proceed to the conversion of units. Example number 1. Convert 3 kilometers to meters. We all know that 1 kilometer in meter is equal to 1,000 meters. Therefore, 3 kilometers multiplied to 1,000 meters over 1 kilometer is equal to 3,000 kilometers dot meter over 1 kilometer. Cancel similar units to lead us to our expected or desired unit. Now we have 3,000 meters. Example number 2. Convert 4 km per hour to meter per hour. 1 kilometer per hour is equal to 1,000 meters per hour. 4 kilometers per hour times 1,000 meters over 1 kilometer is equal to 4,000 kilometers dot meter over 1 kilometer per hour. Cancel similar units to have our desired unit, leading to our answer 4,000 meters per hour. Example number 3. Convert 8 kilograms to grams. We all know that 1 kilogram is equal to 1,000 grams. 8 kilograms times 1,000 grams over 1 kilogram is equal to 8,000 kilograms dot gram over 1 kilogram. Cancel kilogram to have an answer 8,000 grams. Example number 4. Convert 4 feet to centimeters. 1 foot is equal to 30.48 centimeters. Therefore, 4 feet times 30.48 centimeters over 1 foot is equal to 121.92 feet that centimeter over 1 foot. Cancel similar units to lead us to our desired unit, leading to our answer 121.92 centimeters. Last example, example number 5. Convert 50 kilograms to pounds. 1 kilogram is equal to 2.2 pounds. 50 kilograms times 2.2 pounds over 1 kilogram is equal to 110 kilogram that pounds over 1 kilogram. Cancel similar units. We have 110 pounds. Let's now have the worded problems. In problem solving, we should be systematic and complete in writing our solutions. That is why we are expected to write the given down to the final answer. Let's try this for example. Example number 1. A zebra is chased by a lion. The lion can run as fast as 57 kilometers per hour, while the zebra can sprint as fast as 2.55 feet per second. Can the zebra outrun the lion? We now have the given. Speed of lion is equal to 57 kilometers per hour, while the speed of zebra is equal to 2.55 feet per second. In order for us to see correctly the difference of their speeds, we must convert their speed into same SI unit, which is meters per second. Therefore, the speed of lion is equal to 57 km per hour times 1,000 meters over 1 kilometer times 1 hour over 60 minutes times 1 minute over 60 seconds is equal to 15.83 meters per second. Speed of zebra is equal to 2.55 feet per second times 30.48 centimeters over 1 foot times 1 meter over 100 centimeters is equal to 0.78 meters per second. Therefore, as a final answer, it seems that the lion's speed is relatively higher than the zebra's speed. The zebra cannot outrun the lion. Example number 2. Rojas Boulevard is approximately 11 kilometers long. During rush hour, vehicles move slower at about 40 kilometers per hour. How much longer does it take to travel during rush hour? We have the given. Distance is equal to 11 kilometers. When converted into meters, that is 11,000. Velocity is equal to 40 kilometers per hour when converted into meter per second. That is 11.11. And we are looking for the time travel. We have the derivation of formula. T is equal to D over V. We have the solution. Time is equal to distance over velocity. Substitute the values. We have distance is equal to 11,000 meters divided by velocity, which is 11.11 meters per second. Cancel similar units. That leads us to 990 seconds. Therefore, it takes 990 seconds to travel in a Rojas Boulevard with 11 kilometers long during rush hour.